Welcome to EDU 3339, Chapter 12, Addition and Subtraction. In this session, we are going to discuss computational fluency, student-invented strategies, estimation strategies, and then discuss the additional videos. Computational fluency. What is it? Well, if you remember reading fluency, it's basically the student being able to decode in order to comprehend and to understand what they are reading. So to do that, they have to have proper rate, proper accuracy, and proper expression. Well, it's kind of the same way with computational fluency. We want students to be able to solve math problems with ease, to not get stuck, and if they do get stuck, to know what to do to get themselves unstuck. So how can I, as a teacher, practice computational fluency in order to help my students? Well, you have to know that there are different types of computational strategies. The book actually highlighted 3 of them. The first one being direct modeling, and that's definitely the most concrete. It's when the teacher stands up, models, and then the student actually solves problems by using models. So they'll count things or they'll use their base 10 models to solve problems. Now eventually the student will leave that, but direct modeling is what they use to start to understand math. Another type of strategy is the student-invented strategy. Now, student-invented strategies have become more and more popular recently with Common Core because we want students to solve problems the way their own brain works. There are different types of student-invented strategies, and you may not understand some of them because the students invent them themselves. But if we ask students to support their strategies by using something written, it could be their own algorithm, and then to be able to explain their mental methods, we can determine whether or not these student-invented strategies will help them be successful with math. Finally, we also have the standard algorithm, which is what many of us are used to because we were shown how to solve math in that way. So let's talk about the contrast between the student-invented strategies and standard algorithms. First of all, let's say that we have a number, 423. If we were to use the standard algorithm, we think of each digit separately and of its value, like 400 and then 20 and then 3. But a student might think of that number as 2 less than 425 or 3 more than 420 or something close to 400. Also in our standard algorithm, we add and subtract by starting on the right. We call that right-handed. Okay, and then we move in backwards kind of to the left to larger denominations of the digits. However, with student-invented strategies, they could actually start their computation on the left. We'll look at some of those in just a few minutes. Also with standard algorithms, basically one strategy is used for all computations. So 413 minus 237 is done the same way as 400 minus 8. However, with student-invented strategies, those strategies are flexible, and I may use a different strategy to solve 400 minus 8. So here's an example of a student-invented strategy, 23 minus 19. The student actually added up, well, 19 plus 1 is 20, and then subtracted 23 minus 20 equals 3, and then just added that 1 back in. So their answer would have been 4. You can see that to help students develop their own strategies, we have to give them a little freedom. Okay? We want them to understand place value, but we have to give them freedom to be able to try some things on their own. We need to encourage them to use various methods that we show. So we might show how to do a problem this way one day, or a second way the next day, or maybe a couple of ways in one day, and then let the students choose the way they want to solve it, or perhaps adapt in some way so that they are solving the problem themselves. So let's look at these. Instead of using a standard algorithm, let's think how we would solve these problems. So I'm going to walk you through how my brain would solve 465 plus 230 if I didn't do it in the standard algorithm. Well, I would definitely start on the left. I would say, well, 4 plus 2 is 6, so that must be 600. And then I would say 6 plus 3 is 9, so that must be 90. And 5 plus 0 is 0, so that would be 690. You see that I went from the left, I did not add from the right. If you take the next problem, 526 plus 98, I wouldn't even solve it that way. I would say 526 plus 100 would be 626. Then I would just take 2 away, and the answer is 624, because 98 is 2 less than 100. Then I would solve the subtraction problem in even a different way, because I can think of quarters as 25, 50, 75, and $1 or 100. So I know that if I'm subtracting 25, I'm going to get 75. So then the answer would be 6,975. That was easy, and I didn't have to do all that borrowing and regrouping from those zeros. See, I used my own strategies, and I was able to explain them to you. And that brings me to this. This is a rule that I always had in my classroom. If you use it, you have to be able to explain it and know why it works. So always encourage your students to publicly share their strategies and maybe answer some questions that other students make, because that helps students sitting in their seats to construct those new ideas. So here's another student-invented strategy on the right. You can see how this student did. 73 minus 46, they separated the 40 and the 6. Kind of pushed the 6 aside for a moment. 73 minus 40 is 33. Now take the 6 and divide it into 2 steps, minus 3 and then minus 3. So 33 minus 3 is 30, and then 30 minus 3 is 27. That's a pretty ingenious way to solve that. Now let's talk about computational estimation techniques. So we're going to talk about front end. Front end estimation basically just takes the front digits of the numbers and does an estimation. Now we do know that we have to make some adjustments because of the next column, because that may prove some problems if we don't. But if we are estimating this particular first problem, problem A, we would say that that's 12, or about 1200, because 400 plus 600 plus 200 is 1200. So we could stop there and say that our answer should be somewhere around 1200. But by making an adjustment with our hundreds place, we know I would add 5 and 3 is 8, plus 8 is 16. So I would know that I needed to add about, I would even say 16 more, or 160 more. So my answer is going to be somewhere around 1350 to 1360, adding those two together. So sometimes we have to be that precise in estimation, and other times we don't. So provide students problems like B, where they're price tags, and we say, about how much money would these 3 items cost? Well, if I do front end, in the first one I don't have anything in my thousands place, so that's 0. 4 and 2 is 6, so I know it's at least going to be 6,000. Let me see if I need to make any adjustments for my hundreds place. Well, I know that 7 and 3 is 10, plus 2 more is 12, so that would be about $1,200 more. So added that to my 1,000, that's going to be about 7,200, 7,300. So I know that's going to be quite a bit of money. And if I only take 6,000 to pay for this, I'm not going to have enough. Then we also use what's called compatible numbers. Compatible numbers are numbers that you can add together to make something quickly, to make a number like a landmark number like 100 or 50 or 25. And you can see that if I'm looking to kind of match these numbers, I get the ones that are closest to each other. Like for instance, 85 and 17, very close to 100. It would be 102, but it would be 100. If I'm looking at the 65 and the 29, that's also very close to 100. And then the 41 and the 63, also very close to 100. So about 300s. Now the 48 wasn't used, so I'm going to just round that to 50, so I know it's about 350. And then you do the same thing with money down there. We do this in the stores all the time, especially when we're trying to live on a budget. We round things in our head to make sure that we have enough money. We also have to remember when we're shopping, and we share this with the older students, that you have to pay tax on a lot of items. So I usually round up if that's the case. So here are some more compatibles. So we have two prices here. We have a sale price of $128 and then $84. So we're going to change 128 to 124 because then that makes those two numbers easy to work with. So 184 minus 124 is $60. I saved about $60. Now, this is something that a lot of students do incorrectly. They would actually subtract 184 minus 128 and get $56 and say about $56. Well, that's not an estimation, because in order to estimate, you should not have to do the problem. You should do the rounding first. Estimation is the reason why we can go to the store and make purchases without taking a calculator with us. We have to be able to do a lot of estimation in our heads. So here are some suggestions for teaching computational estimation. Basically, give the students a reason to use it. I always used examples of in stores, having enough money or other contexts. Also, accept a range of estimates. If a student estimated to $1,200 but it was really $1,300, I would say that's pretty close if you're looking at thousands of dollars. So you're going to focus on the methods, not necessarily the answers. Now here are some additional videos that I've included for this week to help us with addition and subtraction. We have a couple from the teaching channel that are going to show actually pedagogies. They're both with younger students. The leprechaun traps and the 3-act task are basically kindergarten, first grade level. The one on the right there, subtraction as a confidence builder, would be more for the older students, upper grades, but you could certainly take things from that and apply it to the younger grades. Then I have 2 videos from Khan Academy that'll just help you remember how to regroup if you have kind of forgotten how to do that, or maybe help tell you how to show someone else to regroup. I think sometimes that's the problem. As teachers, we know how to do it ourselves, but finding a way to explain it is difficult. So this week you're going to be doing some explaining in class up at the board. So I would suggest that you go ahead and watch these videos and learn how to explain regrouping with subtraction, and think about how it works with addition as well. Have a great time watching the videos and reading your chapter this week, and I will see you in class.